Now we're going to work through some ways that we can incorporate epoxides into compounds. So this first one is called the Mcpba Epoxidation. And with this reaction, we use a specific reagent known as Mcpba. And that stands for metachloroperoxybenzoic acid. Well, you know what metachlorobenzoic acid is. So here is benzoic acid, and the metachloro would be like this. So the only difference is we have this peroxy group. And a peroxy group is a peroxide. That is when you have two oxygens bonded together. So instead of the OH group in the peroxybenzoic acid, this is actually an OOH. And this functional group here, where you have the RCO3H, that is a peroxy acid. When we add this peroxy acid to an alkene, we're going to get epoxide formation. So effectively what we're doing is adding a single oxygen across the double bond. And when you add a single group from one side or the other, both bonds are going to point in the same direction to that single group. So if we add an oxygen across this pi bond here, we're going to end up with two bonds to the oxygen. But because of geometric constraints, one can't be out and one back. These both have to be in the same direction. So they could both be wedges or both be dashes. Now in this particular case, because this is an achiral molecule, it doesn't matter if we put them out or back, both molecules are the same. But let's look at this second example where we have a single stereoisomer. We have a chiral center with a phenyl group on it. When we add Mcpba, it can add from the front and it can add from the back. So if the oxygen adds from the front, the epoxide will be on wedges. So all I'm going to do is redraw this molecule. I'm going to keep that chiral center with the phenyl group as is. And then where I had the double bond, I'm going to draw my epoxide on wedges for the front. And then if you add it from the back side, we'll put it on dashes. So in this case, we would get two diastereomers. The mechanism for this reaction is actually a single step. So I'm going to draw my alkene and a peroxy acid, and then we'll see how they react. Okay, so here's the alkene. Here is the peroxy acid. I just abbreviated the R group, and I color-coded a couple of things. I made the pi bond red. I made the oxygen here that's bonded to the hydrogen. I put that in purple, and then made this bond to the OH blue. And that's just to help us keep track of the electron flow here. So the way that this single oxygen adds, and it's going to be this purple oxygen that adds across the pi bond, what happens here is the pi electrons in the alkene, they're going to come over and attack this oxygen. The oxygen doesn't want a third bond, so what's going to happen is it's going to send its electrons in this bond over to here. Again, this carbon doesn't want a fifth bond, so it's going to send electrons up to grab the hydrogen, and then these blue electrons between the O and the H, these will come back over and form the other bond to the epoxide. So now let's draw the products that we get. Here's my 5-membered ring. We have the 2 bonds to the oxygen, and then the byproduct is just a carboxylic acid.